Hello and welcome to TidyX episode 126. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. And just a reminder before we jump into this episode, on the YouTube channel, like and subscribe. Drop your questions, comments below. We might answer them in your own very own episode. We've had two in the past 2 weeks. We've had
Yeah,
two, which is cool. Also, if you feel like our work has impacted you, we do have a Patreon page, and we're always gracious of anything that you feel that you'd like to donate. That being said, we're ready to jump into episode 126
let's get it going.
called Pivot Wider but Keep Duplicates.
Yeah, so this was an interesting problem. When Patrick came to me, I was like, I don't think I've heard that, but I also think that it's actually a legit problem. So, Patrick, do you want to take us through what's kind of going on here?
Yeah, so this is a problem I ran into last week. I was working with a model that I had built, and I was running some simulations. And so the simulations were basically this for loop that would run the model over the data and deposit a output of a predicted value and then some sort of range of credible value in 3 columns. And the issue I was running into was when I would pivot my data wider. So I was trying to get the features pivoted wider across the top so that I could multiply them by their respective coefficients and run them through the simulation. Now, the problem that I was getting was that if I had rows that had duplicates in the pivot, it would collapse them down. And so I would, my for loop, once the simulation would run, would bark this error at me saying, you know what? I see 32 rows in the predicted values, and I only see 28 rows of your, of your data set because the pivot wider was collapsing things down. So I was getting this offset. So I needed to try and pivot wider, but keep all the duplicates. And that's how we got into this episode.
Yep,
So
yep. So
there we
I'm
go.
excited. I think this is fun. I think kind of working with Pivot Wider and showing you the different tools and techniques that you can use both within Pivot Wider as well as the setup that you can do going into Pivot Wider to kind of make it do what you want is a super valuable tool. So let's get into this. So we are going to be using the empty cars data set because it is available in public data.
Mhm.
So we're gonna library tidyverse for all our data manipulation needs, specifically the pivoting functions. And we're going to do a little bit of manipulation and setup of our data where we're going to take empty cars. We don't care about anything other than the weight, WT, and cylinders, CIL, columns. And then we're going to convert CIL into a factor. So this is just going to give us a new data set that looks like this, where we've got all these weights and we've got all these cylinders for all these cars. I guess I could have just done the head there and make it look a little bit nicer. But Patrick, what is our goal for this?
Yep. So the goal is that we want this weight column to be sort of the ID column, and we want to pivot all of the cylinder variables out to their own respective columns. And basically what that's going to produce is a Boolean. That's an 8, or sorry, a 0 or a 1 for an 8, a 0 or 1 for a 6, and a 0 or a 1 for a 4, right? So if you think about like a simple regression equation, maybe in this model, we're trying to predict miles per gallon from weight and cylinders. If the regression equation sees that there's 4 cylinders, as a consequence, 8 and 6 would be zeros, and the 4 column would have a 1 in it. And so that's what we're trying to get our data pivoted out to.
Mm-hmm.
And so if we run this, this is what we would want our finished product to look like. Essentially, weight is its own row, and then we have several types of Booleans underneath the 8, 6, and 4. And you can see that we've also put in this example a few of the repeated. So 2.32 is an exact same row. 3.44 is weight is repeated twice, but the cylinders are slightly different. One is 8 and one is 6. And so what we're going to see here in a second is that when we pivot wider on data that looks like this, it's going to do a bunch of collapsing for us. So let's take a look at this is my first attempt and failure. I thought, well, let me just try and pivot it wider. and I get all these arguments, and I get this ugly list. So basically, it's saying, oh, yeah, we see some duplicate columns for, or sorry, duplicate rows for weight. So we're just going to collapse those rows down because we don't really know what the heck you want us to do. And you can see that there's some handy dandy helpers to say, hey, if you want to suppress this warning, add this. If you want to summarize the duplicates, add that. This is a newer version of tidyverse than what I was using. In my version, it basically said, well, you can basically uncollapse these by using this values underscore fn function and pass it the word length, the argument length. And what that's going to do is it's going to uncollapse all of those lists. So if we run that, okay, this looks pretty cool, except if we look at row 7 there, and if we look at row 5, we have 2. So we're not seeing a Boolean. We're basically seeing it's kind of work, but we only have 29 rows in this tibble as opposed to the original 32. So we're still going to get the error that I was talking about if we were trying to write an equation over this entire,
Where if we're
write a
trying to
model over
add
this.
back the data, add back
Yeah.
like the result that we're trying to predict, it's not going to give us that value. Or it's
No,
going to have two values for this row 7 and
exactly.
three values for this row 5, and so that's not what we want.
So what's another way we could try and maybe solve this? Ellis, what about this third approach and failure?
All right, this time what we're going to do is we're like, okay, so we know that there's duplicates within our weight and cylinder. So why don't let's just do a group by. So let's do weight, let's do group by, and then let's add some unique identifiers to try to, based on the grouping of weight and cylinder, uniquely identify all of them. And so that's then a new row or a new column in our data set, and we can then use that to tell pivot wider, hey, this is actually an ID column that we don't want to collapse these. So we go dat, we do group by weight and cylinder, we create this new column called WTID, and just throw row number in there. And so what this does is now we've got this new column weight ID for all the cases where there aren't duplicates. It's fine here, but it's just a 1. But if there's duplicates like 344, it just cuts off here. Oh no, there we go. 344, 8 and 344, 6. It's going to let them be listed separately, and then we add into, so our values are from sil, like what we've been doing, and the names are from sil, like we've been doing. These now ID calls, and before it was just weight. Now we've added weight ID, but we're still keeping this values fun length because we don't want it to be parking any more errors at us, because, well, actually we wouldn't get error messages anymore because these are all one value. But this is not what we want, because as we can see here, the weight ID 344 is still listed twice. One for 6, one for 8. So we still, if we do this regression, we will still be getting two values for this. That's not what we want.
We'd get actually a weird prediction because 6 and 8 would be mutually exclusive. You can't have a car that's an 8-cylinder car and a 6-cylinder car. It has to be one or the other, right?
I mean, there
back.
was
I
an
know
engine
nothing
that would
about
like
cars.
split. Oh, there was this.
Yeah.
Sorry,
I know nothing about
random
cars,
aside.
so.
There was an engine
Yeah.
that could run on like
Okay.
half a bank, and then if it was like overheating, and then it was like a crazy
All right. So it's not
engineering feat,
implausible.
but
Yeah, it's
like
not implausible.
not in this data set. We know our data set, and we know that doesn't exist.
Yes. Okay. There we go.
Know
All
your
right.
data. Be the subject matter expert on your data.
All right. So that didn't work. We're close. We have the issues with weight 344. Let's just take a look at what that looks like. Ah,
So this is not unique here.
no, that's the problem. An 8 and a 6. That's what we saw. All right. So we got one more shot here. Four times a charm, as they say. So here's what I did. I said, okay, I've got my data. I'm going to do the same group by. I'm going to add the row ID, and I'm going to add a secondary ID, which is the weight cylinder interaction. And so basically, I just do a little paste with an underscore. And now that becomes my ID column that I'm interested in keeping, along with weight, which is obviously the value that we want for our regression equation. And if I run this,
Oh, and then
oh, and
what?
I,
Sorry.
I added value. I added values fill 0 so that I don't get the ugly NAs, because obviously it's not a missing value. It's a 0. If it's a regression equation, I want to multiply that coefficient by 0 so it effectively removes it from our additive values once we run the model.
Mm-hmm.
Okay, so if we run this bad boy, and then names prefix sil, so that just got rid of the numbers. R doesn't like numbers in column headers. It puts the little ticks on the sides of them. So I just said let's get rid of that and let's just say sil. So sil 6. And
Yep.
so now we have a 32 tibble that's 32 by 5. It's exactly what we were looking for. Each row is now perfectly represented. And we could take this and we could put it into an equation that says like intercept is blah plus weight times whatever coefficient plus cylinder
6.
6 times, cylinder, 4, 8, whatever, and add them up together and we'll get a predicted value at the end of that column. So we can read across and evaluate what it is we can evaluate the prediction relative to what the model inputs were.
Yep, 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 yep. And that's how you can go and take your pivoting. And pivoting, in this situation, we're not actually pivoting to make it shorter and strictly make it wider. We are making it wider, but we're not trying to reduce the number of rows in our data set. So this is kind of a unique and slightly different way that people can use Pivot Wider. If you've got ideas for how Pivot Wider could be used, we'd love to do. And you have questions about how to use it, drop a comment down below, send us an email, open an issue on our GitHub, and we might use it as an episode in the coming weeks. So that
Yeah.
could be really exciting.
Hmm.
So with that, I guess we're gonna call it for episode 126. Thank you all for joining us for all these episodes. As always, my name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick. At tidy_explained is where we both are on Twitter. Tidy.explained@gmail.com is where we both are on email. As Ellis said, that YouTube channel is usually the most frequent way people get in touch with us. Like, subscribe, drop a comment below if you have questions about pivoting, either wider or longer, or you're running into problems that you're trying to solve. Hit us up there. We had a great kind of more complex pivoting problem a couple of weeks ago from a researcher. That was a pretty cool one. So we'd be happy to solve your problem on the air. And as always, we do have a Patreon page if you feel like our work has positively influenced your work in some way and you'd like to donate to us. We are extremely gracious for anything that you might give.
All right. Thank you all so much. Keep on exploring your world.